Welcome. In this video I'm going to show you how you can perform a Freeman Tukey Goodness-of-Fit test using R or the modified version of that. I'm using R version 4.3. I'm running this in Jupyter Lab, but it should also, the code should also work in RStudio, for example. The packages that come preloaded with R are usually these, and in this video I'll simply go over how you can obtain the output using my stikpetR library. I have a separate video if you don't want to use my library. The video will also only focus on how to obtain the output, not so much on if you should be using this test. It might be that this test is even a little bit redundant. There are a lot of other tests that can be used. I'm also not going to explain too much on how to read the output. It's just about obtaining the results. The example that I'm going to be using is from the General Social Survey 2012. I slightly adjusted this, so I'm first going to load in the data, and then I can use the table function to, for example, show you the data of the marital status, which was labeled MAR1, and we want to see if these are significantly different from each other, and that's the key ID with this test. To use my own library with this, you need to install it first. It's not available on CRAN, so you need to install it from my GitHub. That can be done with this command, with DevTools, and then install GitHub and then stikpetR. After installation, it should be available just as any other library, and the function of interest is TS, short for test, Freeman Tukey Goodness-of-Fit. You feed it the data. If you want, you can also give it expected count, otherwise it will simply take the sum of the frequencies and divide that by the number of categories. It's optional to include a continuity correction, either Yates, Pearson or Williams, and if you want the modified version you can set that to true. So all you need to do is give it the function, give it the field, and it simply spits out everything you probably need. The sample size and the number of categories, the chi-square value, the degrees of freedom, which is usually the number of categories minus 1. The p-value or significance, if that's below 0.05, then you reject the assumptions that they're all equal in the population. It also shows the minimum expected count, which in this case was the same for all categories, and the proportions of cells that have an expected count below 5. Some will say that depending on whose criteria you want to use, that this should be indeed 0 or a max of 20, and that the minimum expected count should be 1 or sometimes 5. It depends a little bit on who you're following on that. And it shows the name of the test. And that's basically it. We could provide our own expected count. So for example, if I would have expected these values, I can simply say, well, okay, my expected counts for these categories are these values. So I'm going to store those separately, and then I can feed that into the function as well as expected counts. Other options using the continuity corrections or using the modified version, here's a small showcase of all of them. I have a separate video, like I mentioned, where I show you how you can do it with the MSC quartets library. It also shows you how you can do it without any libraries except perhaps the stats library from R itself. And that's all there is to it for this video. Alright, I hope this was helpful and thank you for watching.